Welcome to section 5.6. Just a small disclaimer, for our course we will only be covering the first objective of this section. We will not be doing the entire section. So when you do get to your homework, don't be alarmed, it's supposed to be short. All right, so the only objective that we are covering is dividing by a monomial. That is the only division we will do in this class. So I just want to walk through a couple of examples and then you can get started on your homework. All right, so if you are dividing a polynomial by a monomial, what I need you to do is to divide each term of the polynomial separately by that monomial denominator. So rather than having a plus b divided by c, I would like you to do a over c plus b over c. So you're going to break up that binomial into two separate small division problems. And just a reminder, remember your denominator cannot be 0, so keep that in mind. All right, so let's start with the first example. Okay, so we have a trinomial divided by a monomial. So the first thing I want to see is that you're going to break this up into 3 small division problems. You're going to take each term in that monomial and divide it by the denominator. Okay, that monomial in the denominator. And then go to the next term and take that one and divide it by the denominator. And then go to the last term and multiply and divide that by the denominator. Okay, so I need to see 3 small division problems. We do this because then all we have to do is use the quotient rule that we learned back in section 1. So here we go. Negative 12 divided by 3 is negative 4. X cubed divided by x, remember this is x to the first power. When we're dividing, we keep the base, we subtract the exponents. So again, when you're dividing, your powers will change. That is not unusual. All right, plus. Go to the next one. 36 divided by 3 is 12. X squared divided by x is x to the first power. Remember, don't write that first power because my math lab will mark it wrong. All right, here I see that the x's will divide out. So I have 15 divided by 3, which is 5. All right, so there's your answer. And when you are done, my math lab might ask you a question about your answer, just to make sure that you are really paying attention to all of that vocabulary we talked about way back in section 2, okay? Is your answer a polynomial? Okay, so this is a yes. Yes, it is. This is a polynomial. Yes, it is a polynomial. Because remember, polynomials have all whole number exponents, 2 and 1. Those are whole numbers. It's fine. We don't have any negative exponents. We don't have any x's in fractions or anything like that. So we are good. This answer is a polynomial. And notice it's in standard form, highest degree term, in descending order to lowest degree. All right, so this is what I would call the utopian example, where everything comes out perfect and beautiful. We like these, but there are going to be times that they don't come out pretty and beautiful, so we really need to do a couple of examples of those. All right, so here's an example. Okay, it looks very much the same. We're going to treat it exactly the same as we did the last one. So we're going to take each of these terms in the numerator and divide them separately by the denominator. So 30 x to the 7th divided by 5x squared. Then we go to the next term, 10x to the 5th, and we're going to divide that by 5x squared. And then bring down the sign and then do the last term divided by 5x squared. All right, so here we go. So 30 divided by 5 is 6. X to the 7th divided by x squared is x to the 5th. Plus 10 divided by 5 is 2. X to the 5th divided by x squared is x cubed, minus 5 divided by 5 is 1. So x, all right, let's look. X to the first divided by x squared. Remember, we're subtracting, so this is x to the negative 1 power. And what is x to the negative 1 power? Remember, we can't have negative exponents in our answer, so this is minus 1 over x. All right, so there's my answer. Okay, is this a polynomial? No. This is not a polynomial. And why is it not a polynomial? There's one very specific reason, and that is this right here. Okay, can you have an x in the denominator for a polynomial? No, it is not a polynomial at that case. It's still our answer. It just happens to not be a polynomial by definition. All right, one more example, almost exactly the same as the last one. I just changed it up a bit. So if you want to press pause and try this. All right, let's see if your work and my work are the same. All right, so first thing I'm going to do is break up. So each term is going to get divided by that denominator. So I will take each term individually. All right, so there's the 3 division problems I should have, and then I'm going to do each of these individually. 12 divided by 3 is 4. X cubed divided by x is x squared. X cubed divided by y cubed divided by y is y squared. So there's our first term, minus. All right, now here I notice the x's and the y's will divide out, so those are gone, and 18 divided by 3 is 6. Bring down the sign. Here I notice the y's will divide out. 6 divided by 3 is 2, but notice that still that x is in the denominator, so the x is still going to be in the denominator because there's nothing else that I can work with. There's no other x's, so the x has to stay in the denominator. So there we go. There's our final answer. And again, is this a polynomial? No, it's not a polynomial. Again, because you cannot have an x in the denominator. So some of that vocabulary is going to come back in this section, so just keep that in mind. So now you are all ready to do section 5.6 homework. All right, good luck, and we will see you at the Chapter 5 test.